everybody. I hope you're all having a great day so far today. How's my day been? Pretty good. It's cold here again in Houston. Not extremely cold like it was a few weeks ago, but kind of a nice winter day, so happy about that. Alright, so let's get back to the game. Alright, so yesterday we finished up most of the model, and or most of Egg Dino's model, and we actually made it pretty much complete and animated it. And now, today my goal is to make the move command actually work well and look nice with the animations. Okay, so let's see. If we move now, I'm pretty sure it will give us an error because, yeah. Move runtime exception, attempt to index a nil value on line 36. Oh yeah, so here. Okay, so it's saying that user is nil. Oh, okay, well I'm not sure about that or why that is, but a lot of this stuff, or maybe it says 38. Oh wait, what is... Yes, I don't understand, like there's one of these numbers that doesn't make much sense to me. I think this is the line number, and then this is like the function call or something. So, it's saying args is nil here. Oh, well that's not correct either. Because we already ran this code. Let's go ahead, just so I can figure out what's going on. But anyway, like I was saying, we have a bunch of things here that we need to implement. Like this animations object doesn't exist, and we need to implement rotating and booleans, and a new type of coroutine yield. So yeah, we've got quite a bit to do. Hopefully we'll be able to knock out a good chunk of it tonight. Okay, so let's just try this again and see what that prints out. If the user is actually nil, then I need to figure out why that is. Questing speed, Egg Dino. Oh, this is on the framework functions. Okay, so I was looking at the wrong file. On line 8. Oh, okay. Well, the reason is because I changed the name. This used to be just coroutine helper, but I want to try and bring these various functions out into their own objects instead of just cramming everything into the coroutine helper, because it was starting to get really, I guess, what's the word? Not cohesive. Because it had stuff about stat requests and also pathfinding, and then soon we'd have animation wait times and things like that. So I guess let's get started with that. Okay, so here, Lua interface, I have the coroutine helper, and this can stay. But all these other functions will just move out. Or maybe, yeah, this wait frame can stay as well. But these other functions we can move out to something else. So I have a pathfinding results. I'll just create a new pathfinding object. There we go. this should be public, I think. And so the coroutine helper. And again, my dog is being loud, so I apologize for that. But I guess it's good background noise. So yeah, we just have something that like hooked into this and provided us with functions. It might be nice just to have one central object that does that. Or no, probably not. We don't want to like put all our eggs in one basket. Yes, this isn't the pathfinding manager, so I can just have in the object registry, we'll just have something else that has a pathfinding object. This is what I wanted, and so be private, pathfinding. And so this object would just have things having to do with the pathfinding system. Or basically global functions. Alright, so I'll need to copy these over and I'll just go ahead and cut them because we're going to clean them out of there. This is the dynamic value is moon sharp, which is our Lua interpreter. That's what it calls a Lua variable, because in Lua a variable is untyped, basically. Or no, that's not the correct way to say it. It has no strong typing, so it can be any value, unlike in C#. Now if we cut this out, right, so we want to get hooks to those functions so we can call the outside C# classes or C# functions. Cut this out. Should have done this first in the first place, but alright, so now I lost where this was. So instead of calling the coroutine helper, I would just call pathfinding. Oh, except it looks like I didn't make it public. And we don't need access, we don't need a setter, just a getter. Okay, so I think that's all for that. Oh yeah, I should close this. If I clear, it's no compile errors. So let's go back here, or the coroutine helper. Yeah, really just this stat request should go somewhere else. So I'm gonna put that under, what did I call it? Yeah, hidden info requests, because right now we can only ask for stats, but at some other point there may be other things like what abilities the monster has that we would need to request. So I'm just going to try and think ahead and name it something a bit more generic. And I'll just copy and paste these values out, actually cut them out. I need to get moon sharp, that way we have those values, and last but not least, well, before I cut this out, I should have seen what object actually sets this function. But if I pull up Lua or Unity, it will compile and obviously give an error. Yeah, stat request handler. Alright, I need to put this in the object registry. Hidden info requests. And then here I could just call hidden info. There we go. A little cleanup. I think also. Okay, it's still compiling. I wanted to see if there was any more errors, but it was taking a while. I think I renamed this to just any open. I think it used to be any request open, but I will leave the wait one frame in here because that's so generic. You don't really need to have a specific object for that, I don't think. Okay, so done with that. I guess let's just play the game and see where Lua complains again. Hopefully it will get all the way to the execution function for move and we can go from there. Okay, so it crashed again. That framework function is attempt to index nil value. Is it the same thing? Oh, I don't think those values were entered into the Lua namespace yet. Okay, or the Lua global table, so that this guy actually has access to it. Okay, so when, I guess the question is, when do we want those different objects to be available to be called? Okay, I think I actually changed it so that those objects are always available. We just block their, like these Lua requests will only let things through when it's a valid time to call the function. Okay, so I forget when and like what object takes care of putting it into the namespace. I guess I can just call this and see. Yeah, set global. Okay, so it happens in the Lua interface manager. That makes sense. So I can just add more in here. Pathfinding and hidden info requests. Alright, that looks good. Let's try one more time. Oh, that's the exception right away. Oh, okay, I forgot to do one other thing. These new classes I created, they're not able to be put into Lua because I forgot to tag them as a Lua object. So I just have to type moonsharp user data and give it this, what are these called again? Attribute. Also, I forgot one important thing. I need to make sure that this is not able to be called in Lua. I need to just hide the default constructor, or not able to be created in Lua. And this is hidden. Alright. So now we got some more cleanup done. Let's look and see how the game, or how far the game will let me go this time. Alright, another error as we expected. Okay, so now we get to ability scripts, line 39, attempt to index a nil value. And line 39 is, yeah, so this facing object doesn't exist, of course. Alright, so let's see. I want to see what it printed out. Oh yeah, so it is printed out egg dino because that's the name of this object. Okay, so first thing we need to do is figure out some object that will be a facing direction. And then, like, we already have this do move. I guess we can look at that. What is it? It's the, I forget if it's the action logger or action list. The action logger. Oh yeah, I think the difference is that the action list is not exposed to Lua. And it just keeps track of actions executed in the Lua code so that the Lua objects can kind of like pretend that it's actually happened. Because the game doesn't execute actions right away. Although we might actually be able to, because we have this yield. I was thinking that we'd have a coroutine yield and it would wait until the animation is done and then do the move action, but not sure. I need to go look and see exactly how we handle that, because I think I might send the actions to the server and then execute them afterwards, and if that's the case, then I do need to change the way that this is handled a bit. Yesterday when I was planning, I didn't have coroutines, but then before the stream I remembered, oh yeah, I already have this cool coroutine system, so I can just use that for waiting on animations. It'd be nice if I could do that, but I don't think I can. Alright, so let's look. What does the ordering finalizer send? Yeah, so it sends a list of actions. Which I guess I can see where these are created. Action creator. Okay, yeah, so we call the Lua script for every selection. Yeah. Okay, and then here is the class that actually calls the Lua. Okay. Yeah, and this all happens before, like, because we have to generate the actions and then send it to the server, and then the server will give us the go-ahead. Okay, so that's yeah, a bit of a shame. Unless I want to kind of cheat and have it not really pause at this point. Because I can think of other times when it'd be nice to have this coroutine. Because say we wanted to play a certain animation at the beginning of a turn before input started. But yeah, I guess we just can't. So I guess, yeah, for that case, we can just use the same animation system, but then have like a coroutine yield wait for playing animations or something. But that might not be needed until down the road, so I shouldn't worry about it too much. So in that case, I still want something kind of like this coroutine. Maybe what I can do is just insert the wait into the action so it'll know to wait for that animation to finish. Because all these animations kind of need to be stored. I don't really want to, we won't really want to send them to the server because the server doesn't care about the animations, they just care about the game state, which would be these actions. So I kind of want to keep actions and animations separate. Let's call this actions freeze, and then we'll just pass this coroutine request object, and it'd be the same thing we would pass to the coroutine yield normally, but instead we'll use this to know when to wait to execute actions later on. I think that should work pretty well. And then the animation object will just know that when we're in this certain function that it won't actually like immediately set these animations, instead it will just add them to a list to do later. Okay, so let's update this as well. Basically what's happening here is we're going to set a boolean in the animation system, which if you remember, let's open up EggDino and look at the animator for it. We have these parameters. Right now we just have move, but we'll also want rotate. I guess, yeah, we should rename move to walk, and then we'll have jump. And we'll set these parameters in the animation state machine, and that will decide which animation we'll move towards. And then in these transitions, it will like blend the animations together and make it look smooth. So instead of move, this should be walk. Then we'll have jump and rotate. Oh yeah, right now walk is a trigger, and the difference between a trigger and a boolean is that whenever a transition takes a path that required the use of this trigger, the animation system automatically sets it to false. But we don't want to do that because we want to toggle these states on and off to let the animation system know when to exit its a certain animation. So walk. And I guess we could go ahead and create the state machine while we're in here. Have a bunch of different animations here. We rotate and jump. So I'm gonna just kind of be a bit lazy here, and we'll see if it doesn't look good. But okay, so we set exit time because we turn this off because the animation will exit based on a condition and not a time. But I'm going to just tell it that whenever walk is set to false, that it will move out of this node. If this doesn't look good, like if we move straight from walk into a jump, for example, then we need to add another transition from walk to jump just to make it look smooth. But we can just kind of do it this way and cheat, and we'll see how it works, or how it looks, I should say. So when jump is true, we move here, and then exit time turn off, and when jump is false, then we do the same thing for this one. State machine system is pretty powerful, although it is a bit, should I say, like tedious to work with, because you can't copy and paste these transitions as far as I know. It is a little annoying. Turn exit time off. Okay, so now this is all set up. Okay, so here we set the rotate boolean to true, and so then the animation system would move to rotate. And then we'll actually do this rotate movement, which will take the egg dino object and physically rotate it towards a certain facing that we provide. And here is like, I want it to rotate based on a specific speed, but we could also maybe rotate based on a time, move from the start to the new facing, and even have it rotate in sync with an animation. So I want to try and support those 3 different types of durations, I guess. And then here we tell the animation system, or I don't know, we just tell the game that it shouldn't execute an action until this animation is complete. And then once this is done, we set the boolean rotate to false, then it should move back to idle. And then we actually do the move action, where the game will, in its own logic, move the position of the monster to this selected position, which I should really move this, or change this to target and user. And this function is already complete, although yeah, we're going to need to change some stuff to get it to work with animations, I'm sure. And here, if the distance from the start to the target is 1 and they're on the same layer, then we'll set the boolean walk to true, so it'll go into the walk animation and do a linear move. Otherwise we'll do a jump animation and an arc move, which would just, I don't know, jump in a ballistic arc. We'll probably kind of fake it, because that's kind of difficult to do and have it look good for all positions, but we'll see. And then another freeze to wait until that animation is stop. And then we just turn both those flags to false, so it'll go back to idle. And we're done. We could add a lot here, like I said here, sound effects. I'm just not going to worry about that just yet. And also, you could have a landing animation and things like that. But I think this will be a good place to start. Alright, so I guess I'll take care of the facing first. So we'll need a new class. This will be like the helper function, or the helper class. So we'll have something like, I guess, yeah, first I need to make this ARP hidden, make the constructor hidden. And this will be ARP user data. So, do I want this? Okay, so we need an actual object for facing, and then I need like something that's like facing utilities. Maybe I'll do that. Okay, so the internal value would be something like X vision neighbor. Okay, and then I guess I'll have an override toString. Okay, so I think northeast is 0, so we'll start with that. I don't need a break. Could just return a letter like I do in the actual game logic, but I think typing out a bit makes it a little more easy to use. Northwest. Okay, and then I need to have a default. I guess I'll just return unknown. This should never actually happen, but and yeah, see, these objects are so, this one's gonna be really small. I think I'll go ahead and just put the utils class in here as well. This will be a sharp user data facing utils. Oh, I forgot the class keyword. Okay, yeah, let's call this. I guess I'll just value. And again, we need to hide the constructor. Fit in. We might need to, yeah, this will need to have a reference to the Lua registry, I think. Because, yeah, there'll only ever be 6 possible facings, so we can just store them in the Lua registry. Okay, and it will have a constructor where we'll pass this. I have to hide the default constructor, so that's why I have one in there even though it's empty. We can throw system legal. Okay, we'll just throw an exception. Never be called, but okay, so we'll want to just have a way to, I don't know, create a new one. and it will pass some string. And then we'll basically convert this back to the specific facing object we want. First, let's go to Lua Object Registry and figure out how I'll store this. So we're going to need some more things in here. This class is getting pretty big. I'm starting to think I might want to split it up, but I don't really know how. Oh no, that's not what I want. Facing utilities. Yeah, there might be, because I originally made this just to kind of like cache these objects, but then I started adding more and more things onto it. Might be a better way to do it. But I mean, it's still, its purpose is just to store various Lua objects, and in that case it's not like out of scope, but it is just starting to have a whole lot of different objects. We'll just have 6 of these. Go ahead and create them now. Facing, just set the value to, oh no, X position, neighbor, I. Oh yeah, we don't want a semicolon there. And that's the only, excuse me, that's the only facing objects that will ever exist. Okay, so here we're going to convert the other way around basically, so switch name to upper invariant. I guess, yeah, if string is null or empty, should throw a runtime exception here. Null string past to create facing. That takes care of that. So I'm just going to kind of delete those. I don't have to type these. Oh, and then I need to change this colons instead of semicolons. Okay, so northeast, this would be return the registry. Facings, oh I don't have, it's not a public value yet. Well, you know, yeah, this shouldn't be public. I should instead make a get facings. Position, neighbor. I guess I could do just in time creation of these objects instead of creating them all in the constructor like I do for most of these other values. So if we want this index, if index is less than 0 or index is greater than 6, then we'll want to throw, or no, yeah, we'll just return null. facing's index is null, then we'll create it. Okay, and then last but not least, we'll just return it. Okay, that looks good, and now I can get rid of this code right here. Yeah, I think I should clean this up. Yeah, sometime we need to go and knock out a bunch of these. So clean up the object registry. I mean, it's fine right now, but I don't know. We're just going to keep on adding more and more stuff to it. It's going to keep getting bigger and bigger. Alright, so anyway, registry get facing northeast. I guess I shouldn't return because I need to check if it's null. And now I'm going to need to break. I'll just copy this and update the narration. And I won't need the default anymore. East, southeast, southwest, west, and northwest. Okay, so if facing equals null, then we'll need to throw another error. Go new script. Runtime exception, bad facing. Okay, now if we finally get down here, then we're just fine to return that to Lua. Alright, so that's good. Now, public facing, what did I name it? I think it was just towards, wasn't it? Yeah, so we take a position and then another position, and we want to calculate the facing if we're standing here to face towards that position. We have block position. Oh, I call it the board position. Let's call it at and target. Okay, so this isn't that difficult. Basically, we'll just take the difference between them. Is so I always forget the order. If the target is to, yeah, so it's target direct at, and I think I need to call hex position. Okay. Oh, okay. I was wondering why is it giving me an error, but it's because obviously I need to type hex position right there. Alright, so Do I already have a function for this? It seems like I might have written it. Oh no. I think how I'll handle this is I'll find the axis that's the biggest. That's a good point, actually. I just realized, because I was going to say, well, we'll still use this, but we might. Okay, let's open up the game. They'll let me run it. Okay, so I'll just return null for now. Okay, it's compiling. I want to show what I'm thinking of. The way I'm doing it now. Oh, okay. The facing utilities I need to. Yeah, I'm glad I created that. I just need to pass the registry to it. Okay, so let's say I'm this monster and I want to move to here. Obviously I would need to do a jump, so it's fine that it doesn't match up exactly with like a neighbor direction. And the jump would look better, and especially since we're in 3D we can actually do this, if the monster turned to face exactly towards the jump instead of snapping to the nearest hexagon. And in that case, might want to use like an angle instead of an actual facing. So, I guess we can still use the facing utilities, but it won't actually return a facing. I'll go ahead and finish with this object, but I think this new facing I might change it to be an angle. Okay, so let's have towards facing, and then we'll have a specific towards angle. That's another thing, actually. What I'm trying to do here. This do move should probably also specify a facing here. Or maybe it should set facing just be a separate action. It probably should, actually. So action set facing. There. Facing. And I guess we should have another rotate to rotate from the jump. Oh, that would go down here, wouldn't it? Yeah, to rotate from whatever the jump facing is to the... or whatever it rotated to its final facing. Yeah, well, let's not. Getting kind of complicated. Let's wait and do that. Alright, so here we're just going to try and snap to a specific hexagon facing, so it'll be one of the cardinal directions on the hex grid. And to do that, we'll just take the largest axis on this difference. Okay, so what did I call the three axes? Oh yeah, the sum is the third one. So the row is, we actually want the absolute value. And the column, absolute value. And the sum, absolute value. And yeah, we can't face upwards, so we don't even need to have the, or even consider the layer. I call that sun, that should be sum. Okay, so if the row absolute value is greater than the column, then if row absolute value is greater than sum. Oh no, let's not do it that way. Yes, then we would either return east or west. I'm pretty sure. Yeah. So if, okay, let's do it this way. There could be an error here also if these are all 0. If difference row is 0 or difference, or not or, if they're all 0. Script runtime exception, at and target are equal, cannot compute. How do you spell compute? Facing. Oh yeah, it's not supposed to be return, it should be throw. Okay, so this is how I want it to work, because either of these can be 0, it's just, yeah, row has to be greater than or equal to both. So yeah, if different, oh, I spell difference. So if the row is greater than 0, then we'll return. Let's not do it like that. Registry, get facing, and then this would be hex position neighbor east, otherwise west. Okay, so next we'll go to the column, so if that is greater than the row and greater than the sum, same thing, except obviously with a column. So the column is this diagonal, so that is northeast and southwest. Okay, and then the final thing, which would imply, yeah, since they can't all be 0, and the row is not bigger than both, and the column's not bigger than both, then that implies that the sum must be bigger than both. So we don't have to do a test here. Okay, so positive up that way. I think. I might need to test that out. Let's bring up our little diagram. Oh, delete that because I moved the file slot. Okay, so here, yeah, the column moves up, and then sum is like the addition of both of these. So both of these sum to 0, I don't think. Oh wait, no, it's like it's actually like the negative sum, but so yeah, I think if the sum is positive, then that means that's facing southeast. Then negative would be northwest. Yeah, because I think the 3 axes come out that way, and that way. Look it up on that one website, but I'm pretty sure this is correct. I was trying to open up exposition, but I have too many objects open. Yeah, so we can see the sum here. Okay, so we can see for this to be positive 1, then the column could be, or the row could be 0, and the column would be negative 1, which, yeah, would be, or the row is 0 and the column is negative 1, that's west. Oh right, the row moves that way and the column is this way, and the sum, does it go that way? Okay, this is beginning to be a bit more than I thought. See if I can find that website real quick. I think I saved it. Yeah, this Red Blob Games has a really great set of tutorials. That's about just pretty much all the math you'd ever need for a hexagon grid. It's redblobgames.com. So let's see. Does it have? Yeah, coordinate systems is kind of what we need. And our game has pointy topped, and we're using axial coordinate. This has these two, so the third one would be that way. So I guess the positive is northeast. So the blue here is the row, and for us, the red is the column, and then this green is the sum. So when the sum moves to 1, okay, so it's that way actually. Yeah, so my math was correct, although that makes it a little difficult to figure out the facing towards. Okay, so yeah, I guess this distances would maybe work. No, we don't really want to find the distance. We want to find basically which way we're facing. Rotation? No, this is like rotating. Not what we need either. I mean, sometimes we'll want to know which hex it should be in. Could use that, but okay, well unfortunately it doesn't have exactly what we're looking for, so I'll need to try and figure it out. Yeah, the sum axis is just not that useful, which is why I don't think I've used it yet. I think maybe find the pattern if I look here. Basically, I want to find this. Well, in our game, the columns are actually moving this way instead of backwards, so it's kind of mirrored. Maybe is that the issue here? No, because it's blue, or the magenta is just our columns. Maybe, am I thinking of this the wrong way? Let's see, so if, yeah, I think there might be an easier way to do this. Look back in a diagram. So, for instance, if we were here and we moved here, and we wanted to look here, we'd see that the columns, when we subtract that, the column goes to 0, which means that it must be on this axis. So when we look from that, we can say either up or down. Problem is that if the facing is not a neighbor, then we want to round to it. Then we couldn't use that 0. But that would actually work for all these, because then if we were here, we would see the row is 0, so we know that it's either east or west. And then if neither one, or both of them aren't 0, we know it's on this third axis. So we can use that for neighbors. Not sure. Another way is that we could convert the distance to an angle and then snap it. That might be the way we have to do it. Okay, so yeah, basically all this code is not useful. Yeah, so if the row and the column are 0, that's really all we have to do. So the distance in axial coordinates, let's look at that just sure. Now my brain is kind of getting a little fried, but so we know how to do neighbors, that's easy. The distance we actually need to, yeah, it's not just super obvious. The difference between the columns and then the difference between the rows and then distance between the sums. Except let's subtract. Oh, yeah, that's just a. And then it does a divided by 2. Cube distance is really easy. Okay, and the reason we have to divide by 2 is because even though this one is just one distance, we can see that these values are 2 of the values have changed. That's why it divides by 2 at the end. Okay, so this distance isn't actually that difficult. It just is taking the difference between the column, the row, and then the sum value. Do I already have that in here? No, that'd probably be useful to add. Public, static, int, distance A and hex position B. So we'll just return mathf A dot column. I don't think I can take the difference because that would mess up the sum, I think. Also, we don't care about the layer. A dot row plus B dot row. Or no, I'm adding, this should be subtract. A dot sum plus B dot sum divided by 2. And in fact, in case I get confused about why I have to divide by 2 because it's not immediately obvious to me, just put a link there. But that doesn't super help. Yeah, again, yeah, I know how to find the facing if they're right next to each other, but not otherwise. I wonder if there's some way that I could take anything and then just squish it down to be next to me. How would I do that in a way that would make sense? I don't know, I'm spending a lot of time on this one. It's actually supposed to be pretty simple. Yeah, so we'll just constrain this to be for neighbors right now. So hex position distance at target greater than 0. Or no, greater than 1. Although I will need to collapse this down because we'll need to know how we'll use this function to tell us how to face at the end of the movement. Yeah, so we will need to do this. thinking, like if it's straight diagonal, we basically would subtract one from each, and then that would give us oh no, we want to move it towards here. We have the row and my system, the column is green and the row is, oh wait, no, the row is green and the column is, yeah, they kind of, this coordinate system is inverted from mine because my rows go up and this is also, oh wait, no, this is positive column. Yeah, this is positive row, okay. I was getting confused. So the green is the row axis, and then the column axis is, okay, so it is opposite, but column axis is negative pink. So say if we were right here and we subtracted one by each, from each, that would give us 0, 0, 1, which is, or that would give us 0, 1, which would be here. So I wonder if that worked if we just like kept no, because if they're equal then we'd be on one of these axes. Yeah, this coordinate system actually doesn't match up with mine at all, does it? Yeah, so I don't think that's being very helpful to me. Yeah, this is more correct, except for me the columns. I don't know, I'm having trouble reading it because here, this should be the column, which I guess is correct. Okay, I see. Yeah, I don't know why I was being confused, but I think for me, the 0 is actually here, for the column goes from the bottom left to the top right instead of this diagonal. Can test. Just return null so I can actually compile the game. Yeah, if we look straight down, yeah, the game world moves up here, and this is 0, 0, and this is 0, 1, 0, 2. And then the columns move this way, and the row axis moves this way. But yeah, I guess we can still kind of use this. So say I was right here. Maybe what we do is we move one column. Okay, so I guess we'll subtract. I guess it depends on if we want to, how we'll take care of ties. But I guess we'll subtract the row first, so that would bring us down here. And then we'll notice that this is a neighbor, so we'd stop. But here, the trouble is this third axis, because I think one way we could collapse it is find the smallest axis and then subtract the other two by that. But it's difficult to. Maybe we need to have like a cube coordinate system for this. It's right here. Because then we'll have 3 axes, so it'll be easier to deal with them. And to convert between them is not that difficult. Yeah, so convert from cube to axial. Yeah, all we have to do is just throw away the third coordinate, so. Okay, so I guess the row would be. But I guess we'll still use the difference because we kind of want to recenter everything on the start position. And yeah, if the row and column are 0, then there's no difference, so. Int column is difference column, and int sum is difference sum. So now I guess we'd want to find the smallest one of these and then shift it so we change that column to 0 and adjust the other columns to follow suit. And then we need to do the same for the last two. But I'm trying to think how's a clean way to do that besides having to have two sets of 3 if statements. Or was my original thing gonna work? Because that's basically I'm doing the same thing. I'm just finding which of these is bigger than the other two. For some reason the sum was confusing me, but well, I guess worst comes to worst, we've just learned a lot about hexagon coordinates, but I think I might have just been confusing myself this whole time. Because if the sum is basically this green coordinate, then if it's the largest of everything, then that is, I guess, question. I just don't know which direction is correct. So maybe we should test that. I just need to find a new way to do it. Okay, so let's just undo everything. And get back to where it was here. And we'll just run a little test where we'll just call this towards facing on a bunch of different configurations to figure out the correct, well, let's see if the facing is what we expect. So I equals 0, I less than 6. Debug log. Maybe, and this code should probably actually be in the hex position itself instead of in this. Public, static, neighbor. So I guess this will just be snapped. Facing towards. I guess I'll use the same names, at and target. That way I can just copy this. Oh, I needed to copy that too. And we'll still handle this, but if they're all equal, then we would just, I think we just return east, which is fine because that's the 0. Okay, we don't have to do that. This is the code we actually want to test. We'll leave that for now. X position. Snapped facing towards. I'll just start it at some non-zero. I'll make this easier on myself. X position, start. We'll make these different, just make sure there's no bug there. Actually, I should just start off with 0 and then test something else. Okay, so at plus X position, axis, vectors. So basically we're just going to test the neighbors first, and if that works we'll try different values. Okay, so they should show up right away whenever those Lua objects are created, which I think is pretty quickly. Look, 4, 6. Okay, it's actually after we load everything. Okay, so here. So east, northeast, west, west, southwest, east. So not exactly what I wanted. So let's look. The first vector, yeah, is 1 on the rows. So this should actually be northwest or northeast. Oh, but I did this wrong actually. Yeah, so this, yeah, these should be swapped. Column. Oh, but I can't just do that. So we test rows first. So this should be northeast and southwest, and then the columns are just east and west. That was my fault. But still there's other bugs, so let's just go with this first. Alright, so now we've got to roll up. The northeast, east. Then it switches to southwest, does that twice. So yeah, something is just wrong again with the third axis. I guess this never happens because I don't think we ever see a southeast or northwest. What am I looking for? Yeah, right here. Let's print a little bit more. Format. At, and then at plus, guess I'll try not to be so lazy. If I can spell right. Nope. I think I need another parenthesis. Alright, so now we can see what each of the positions is. But I think I don't actually, yeah, the sum is not part of the debug print, but we could just figure that value out ourselves. Okay, so here we're just moving up, so that's right. And we're moving east, and then here we're moving up, so it's north, and then also minus, so it should be northwest, but it's giving me southwest. Okay, and let's look and see why that happens. So southwest happens when the row is greater than or equal to the column and the sum. You know what, let's just debug and then we can, instead of having to figure it out ourselves. That. Column. Oh, let's do it the same way that it's debugged. That it's printed, actually. So column, row, sum. Okay, so now it will actually be, I'll just spell it out for us in this debug log. Less math I have to do this late at night, probably the better. Okay, so up here, again, column 0, row 1, sum 1, which makes sense. Northeast, which is right, and here is right. Okay, so what's happening here, I think, is the row is greater than or equal to the column and greater than or equal than the sum. So that means the sum axis is not actually helping me here. But if we look here, I don't know, this grid is just not, the way I've done the coordinate system must not be the same. Although I think I do all the math the same, I don't know. If I move like its axis, third axis is here, so we move one column and then one row down, which in my, so that should be southeast, yeah. Because yeah, it's east and then down, so southeast. Okay, and yeah, so the sum of this is 0 actually, because it's 1 minus 1, so I guess that makes sense, but then how do we, that third axis? Because here it just says to throw away, or to convert cube to axial, you just throw away, and then axial to cube, just, maybe, am I doing the sum wrong? Because it's x minus z. I'm doing negative x plus z, but that's the same thing, isn't it? Kind of want to just move on, but we are going to need this. So I want this to be southeast. So I would have expected. Well, no, I guess this makes sense because we're moving one column and then minus one row. So even maybe the problem is that I'm subtracting them. So maybe I can't just subtract them like I'm doing. I need to actually take the difference of each of their coordinates. Let's try that. Because yeah, there'd be a different sum for it. Yeah, this third coordinate just kind of complicates things. Don't really use it much. But for here, because we care about that third axis, we need to figure it out. There's an error. Oh, I deleted the difference. Yeah, so we, I guess instead of just taking this difference, this would be if target row is greater than at row. And then, oh, it's functionally the same for the row and column, but not the sum. Okay, so let's hope this makes a little bit more sense. Okay, so northeast, east, oh no, it's still doing the same thing. Well, I guess I should have expected that because the at is 0, 0, 0, so. If I look at this, maybe the thing is to actually look at which, because I was kind of onto something. If the column is 0, then we know that it's on a certain axis. And I can see that for both of these sums, they're only 0 when it's on the sum axis. So maybe instead of trying to find the biggest one, I should actually try to find the smallest one. Okay, so I was kind of onto that, but I'll just comment that out in case I need it later. So let's do east and west, give that priority. So if the column is less than or equal than the row and less than or equal to the sum I think that for some values this won't give a really great answer, but it'll work I think for all the neighbors. I'll just copy this. Then if row is less than or equal to column and row less than or equal to sum, Okay, so let's try that. And if it works, at least for the neighbors, then I'll consider that a victory. Okay, no, that doesn't work at all. Which, yeah, I guess makes sense. Okay, well, let me, maybe I can find another website that'll help me. So, X grid determine facing towards, okay, this page seems to be more about the design of it, not math. Well, you know what? It's 9, so I know it's not been quite 2 hours, but I think I'll call it here because, yeah, I'm just knocking my head against a wall. You have nights like this, and we still got a little bit done, mostly planning for the Lewis, so I'm not too mad. Maybe I'll definitely take a little time to research, and hopefully I'll have a good algorithm for you guys tomorrow. But yeah, thanks for putting up with me tonight and coming by and watching. I'll be back tomorrow around 7:30 or 8:30 Eastern. If you missed any stream and you'd like to catch up, I do have a YouTube channel, and I also have a Discord if you want to chat with me throughout the day. If you'd like to be notified when I go live tomorrow, feel free to follow me here on Twitch or also on my Twitter. I'll tweet there. And that's about it for me. So now I'm going to give my brain a rest and, like I said, conquer this problem tomorrow. And I hope to see you then. I also hope you have a great day, and bye-bye.